Uh, Welcome, everyone. We'll get started. So we're live across the world, so very exciting stuff. All right. Today, I'll be talking about building automated pipelines for infrastructure code. And as I go through my talk and tell you a quite interesting story, you'll see what I mean by that. So the main technologies we're going to be using for that is, of course, Terraform and Packer, which I think you all know quite well over here. Right, so who am I? So my name is Tilen. I work at OpenCredo as a senior consultant, who is also, as was already mentioned, an official HashiCorp partner. So, please do get in touch if you need any of that. And one of the great thing about my job is that I get to see a lot of different stuff, a lot of different environments, ways to build your infrastructure, your development life cycle, and so forth. So today I want to talk to you about specifically infrastructure code, of what I and the team I work with experience with, and what are some of the good practices that you should, in one way or another, follow to be able to scale your infrastructure code appropriately. A quick agenda for today. Since we have I have 5 extra minutes, so I hope I'll make use of them very well. So I'm going to do a brief intro into infrastructure code. I know most of you are pretty familiar with what that entails, specifically Terraform, Packer, and so forth. But I think it will lead great into the next item on the agenda, which is basically common obstacles that we hit once we start off experimenting and eventually using infrastructure code in our project, in our environments, in our whole enterprise, from small to big and everything in between. Once we get through those, we're going to go and say how we can actually improve on our initial designs that we usually take. And what we'll do is we're going to actually apply one of the most common development practices today to our infrastructure code. And using those, we'll see how we can actually greatly improve the quality of our infrastructure code and basically everything surrounding it, management, life cycles, and so forth. And then we'll take a brief look at basically automation. So how do we automate things? And as the title suggested, how do we build pipelines? What do they look like? Which tools do we use? And so forth. Cool. So let me get started. So, what is infrastructure code, right? So there's a few definitions around what it is, what that entails. And I mean, let's look at one of them, right? So infrastructure as code is the management of infrastructure in a versioned descriptive manner, right? So what does that mean, right? So what that means is that instead of going and manually configuring our environments and infrastructure, clicking through a UI, maybe even doing command line operations, we instead describe it and let something else take what we described, apply it, and make it happen, basically, right? So I guess that's one way of looking at it. And when we look at it from that perspective, these are basically sort of a gold standard of tools that we have today in doing so. So we use Packer to, build our images. We can use it to build immutable images. Every time we change something, we build a new image. And, we can have a very good workflow with using Packer to whatever we're deploying, be it, Kubernetes nodes, Prometheus, Grafana, Postgres databases, you name it, you can do it with Packer. And the same with Terraform, basically. It sort of became like the standard way of, I want to create a Prometheus cluster with Grafana connected to it. We can describe it in Terraform and just, make it happen. To show a quick example of, for instance, a Packer, it's basically just a JSON, and what you do is you just describe what you want. So what do I want in this example? Well, let's say I'm using AWS. I want to build an Nginx AMI. I specify my instance type, my region, which image I want to use, Ubuntu in this case, what's going to be my username, and then what do I want to install on it. In this case, I have a script that installs Nginx, but I mean, we can use whatever we want here. It could be a script, it could be like Ansible or something else entirely. And then what we do is we take this JSON and we give it to Packer and say, please build it for me. And it will. It'll like automatically connect to AWS. It'll do everything we told it to do. and it'll build our image, and we can then immediately use it. So that's like the first step. Once we build the image, we can proceed to using Terraform. And Terraform is basically the same thing. Now it uses custom, DSL, but in principle, it's the same thing. You describe what you want. I want to deploy something to AWS, and I just say it, provider AWS. I want to get the AMI I just built. I use a data, block and get the AMI I just built. And then I want to create an instance. I want this one instance to run on my AWS account, and then we feed that into Terraform, apply more specifically, and it just does it, right? So it'll go in and create what we told it to do, and we have a simple, efficient, text-based way of describing what our infrastructure looks like. Now, this is a very simple case, obviously, but I mean it's a good sample to basically show you what we want to talk about today. So this is great. So let's say we're in a company or an organization, no matter how big or small, and we have all of this infrastructure deployed. None of it is versioned or managed or anyway. We want to introduce Terraform. So how does it start, right, introducing Terraform? So like I said, typically we have this network of stuff deployed, be it Prometheus, Grafana, Kubernetes clusters, or what have you. And we say, like, we want to introduce Terraform into this mix. So how do we do that? Well, usually we say, okay, we'll pick one thing, and we're going to deploy. And we're going to use Terraform to deploy it instead of manually doing so. So let's say we picked a service. And in this case, I chose, just as an example, let's say we want to deploy our Nginx reverse internal proxy that we have and use Terraform to deploy it. Okay, great. So we create a project. So we'll create a project. It kind of looks something like this when we start out of. We put some Packer code, so Packer JSONs, and then our Terraform code. We may even use like modules to be good citizens, do proper isolation and modules and everything. And we end up with something like this, basically. This is like a basic project, our new infrastructure project that we want to start building up to replace our manually configured infrastructure. And of course, we'll put in version controls. Like I said, we'll use modules, and we'll even use remote backends so that, for instance, S3 with DynamoDB, so that, different people using it won't interfere with each other. We have a central location of storing state files, and so on. And, we do it. We write it in. We separate by maybe like compute network and what have you. And it's great, right? We completely replaced it. We still maybe manually apply it, like, someone closes it down, applies it, and so forth. And it works very well. We're very happy with it. Our infrastructure is now versioned. It's now in descriptive form. We can reproduce it. It's immutable. It's great. It's exciting. And then we'll say, well, cool. Now we did this one module. Now let's, do more. So we take the next thing. And the next thing is, well, maybe a Postgres database server. We want to, use Terraform to describe that. And then we go back to our project and we start putting in, our network to support our Postgres SQL, our compute instances, our Packer image to support our Postgres cluster, and so forth. And we do that as well. We manually apply it. We have an immutable Postgres now, and it's great. And then we want to do more, of course. And the bigger the organization is, the quicker this will grow, until we start adding more stuff like our Kafka cluster, our Redis cluster, and so forth, until we grow it even more. And we start, maybe deploying Prometheus, Grafana, Kubernetes clusters, Kibana, Logstash, Elasticsearch. And then we start noticing that we moved all of it to Terraform, and you'll notice that these arrows sort of represent all kinds of sort of dependencies that happen between them. So we have our Kubernetes depending on all the other components, and Prometheus depending on this and that. And it starts to become like a web of code that is, still in one repo for the most part, or in one place. We still apply it manually, and it's becoming bigger and bigger and bigger until basically everything starts to go into Terraform, including our cloud services, Lambdas, SNS topics, or, functions, and our network as well. So we come to a point where we've basically moved all of our infrastructure into a Terraform Packer combination, which is descriptive and again immutable, everything we talked about before. Except it now, when we look at it, it turns into something like this, for instance, right? So our project that was before easy to understand, manageable, and quick to spin up an environment is now just a complete mess of basically everything we put in over, I don't know, a course of a year or a month or however long we took to do it. And it quickly becomes quite unmanageable to develop anything in it. We find it hard to find stuff. We find it hard to basically to change stuff. And then, we sort of realize, well, we don't really have any tests. Like we have all of this Terraform code. There's a lot of it in there. And, we change one thing and we have no idea, apart from actually manually running it, if it'll actually work as we want it. Will it break something else? We don't know until we manually manage it. And even if we manually test it somewhere, it still doesn't guarantee us it'll work on all the other environments. Because while we were applying things manually, maybe sometimes we forgot to do it. Maybe someone went into the console or the CLI and changed some things he shouldn't have or didn't put it back in the repo. We start seeing quite a few cracks in our strategy of terraforming our code. We also notice, for instance, in this case, we put our environment configuration, the variables and everything inside a repo as well, because, it should live right next to it. Makes sense. Well, I guess you're sort of seeing where I'm getting from. It can become quite unmanageable, and we're lacking a lot of stuff. Now, an interesting story that happened to a colleague of mine is that he went to a repo kind of like this, and then he said, okay, I want to add like a rule to a security group somewhere let's say for Apache. Okay, he went there, he added a rule, and he said, okay, cool, I'm going to apply this now in my test environment. And it went well. It was like one new thing he applied, and that's great. I'll commit it in, I'll push it up, and now I want to apply it to my test environment, and then after test all the other environments. And what happened was when he clicked apply was this, right? Whoa, right? So it wasn't just one rule he added. It was 20 things to add, 7 things to change, and 10 things to destroy, and then he had no idea what's going on. Clearly, well, looking at it, the first thing was like, well, yeah, somebody probably forgot to apply something or merge something, or what actually happened here, right? We don't have any tests. We don't know. Everything's in one repo. We don't have deployments automated. It's all done manually, so we don't know. And I said, okay, let me go back and check my Git history, and maybe I'll see then what someone changed before I did it. And he opens the Git history, and he finds that, let's say, me did a bunch of commits like this. And then, he goes through the commits and he sees, well, add the new pre-prod environment, update number of instances, enable S3 logging, update a repository to reflect manual changes. Well, wait a minute, those are not actual code changes. Those are just configuration changes for my test or pre-prod environment. That's not actually useful. So he goes down a little bit and he says, well, out of this 20 commits or whatever, the last 20 commits, well, only 2 of them are actually sort of something that is referenced to the code. Maybe I changed some rules over there and allowed added additional access to Prometheus and so on. So actually, most of the Git history was just useless from the perspective of I want to find out what actually changed. And we don't know when the environment was last applied, at least not easily, of course, since we don't have a verifiable trail of what's going on. So what we end up with in general is a large, unmanageable repository, right? And I mean, I talked about one, so there might be like a few, but in general, we get this big mess of code, which is not tested. It is not automatically applied. It is not checked for drifts. Let's say someone went in and edited something, and it's just overall difficult to work with, difficult to onboard new people to work with, and difficult to debug stuff in general. So at this point, we should probably do something about it. So why don't we take a step back and say, how can we make this better? Well, let's think about what we just said. So instead of having one big repo, one monolith, probably heard about this before, why don't we have more, smaller repositories, more manageable repositories, or better yet, individual function scope repositories. This doesn't necessarily mean a Prometheus repo or a Grafana repo. It might mean a monitoring repo or a logging repo or a a Kubernetes repo. Maybe is a good one since it's quite big. So we need to break it up, basically, right? And when we break it up, we need to clearly define what are our dependencies. Instead of having a mishmash of arrows left and right and having everything interconnected, we should lay it on the grounds of, this is our single function scope repo, and these are our dependencies between repo. Now, we want to minimize those, of course, but I mean, there will be dependencies, most certainly. Moving on, we need to build a proper build pipeline. So we had a repo, we didn't have any build pipeline, we didn't have any automation on it. We could make a typo in our Terraform code, make it invalid, and we wouldn't even know unless someone spotted it while doing a PR review. So we should do a build pipeline for at least to check if our Terraform is valid. That's the bare minimum, but maybe even more importantly, to test it. So one of the important things is to test your Terraform code, your infrastructure code, just as you test any other code you built in your system. And of course, cherry on top is to do automatic deployment. So no more manual applies, no more manual plans inits and so forth, no more manual head scratchers when you find out that someone forgot to apply something, and so forth. Now, if you take a look at this list, you probably heard about all of this. In fact, this is the exact same thing we do once we develop, our services, our microservices, or in general, our normal software development. These are the exact same practices. So basically, why not learn from years and years of development and research that went on into creating this amazing microservice pipeline and just take that and apply it here just as well? We want to tweak it a bit, but there's no reason why our infrastructure's code should be handled any differently or should be less important even than our microservice code. In fact, it could be more important, since without this, our services won't actually work. So just let's take that and apply it to this. And what do we end up with? Well, first of all, like with services and like what happened in the past few years, break the monolith. Like, don't keep everything in the same repository. It's difficult to manage. Sometimes it's convenient, but in general, it's difficult to manage, difficult to test, and it just takes a long time to do anything. To develop for it, to test it out, to anything regarding one big repo is a lot of the times the pain. And one of the key benefits we get from doing this is that we get a separate lifecycle per function. And it's the same story where we want to update a new version of Java in our services, and we can't because this one thing over there is using some old stuff that no longer works in the newer version. Same thing could apply here. We could be using we want to do some new things, but some code is holding us back, and having a separate lifecycle allows us to do this. It allows us to go different speeds with developments towards each one of them. It allows us to test them separately, to manage them separately, and in general, handle them separately. So let's say we did that and we took our huge monolith, or even if we're starting from a new, we can just start here instead of over back there. We define, let's say, our three main function scope. We have our monitoring, which is going to be our Prometheus Grafana. We have our Kubernetes cluster. It's going to be our compute layer. And then, for instance, let's say we want to deploy Artifactory, and the way it works, it's actually deployed into Kubernetes. So this is where we would, let's say, define our dependencies, right? So we would say, okay, Prometheus and Grafana and monitoring is not actually dependent on anything. So we can have that as a separate thing. We can manage it separately. We can deploy it anytime we want separately, and so forth. Kubernetes sort of standalone as well. It works. Doesn't depend on anything. But for instance, our Artifactory is deployed in Kubernetes, so obviously we can't deploy Artifactory until our Kubernetes is actually deployed. So we have a dependency there. And the reason I highlight them is that sometimes we may need certain outputs that come from our Terraform of Kubernetes that need to feed into our Terraform from Artifactory to be able to actually apply that code. And this is where defining this is important. And Terraform has there are a few ways to handle that passage of data. I know Terraform has one such way. It's just using Terraform remote state. If you're using like S3 or any of the other ones available, you just reference this and say, okay, I want to use that remote state, get all the outputs and use them as my inputs into, to provision my Artifactory server. And while we're doing so, let's also separate out our configuration. We saw that we had like a repo, and a lot of times it happens where we have our code and configuration in the same repository, and it just messes up our history. Doing a change to configuration, like changing the number of instances, and doing a change in our Terraform code are two distinct things, and they should be kept separate. So let's also separate them out into two, basically into two different repositories. Now, how do we separate it out? There are, more than one ways. You could use TerraGrunt is a good library. Check it out if you haven't yet, where you can like dynamically import. You can link your modules to your configuration code, or you can just use your the modules source property, where you can just specify a remote Git repo to use as your module source. So there are multiple ways you can link those two together. I won't go into specific about which one, but do check a few options out. Great, so now we have this, and once we have that, we'll take one repo, for instance, our Kubernetes cluster. In this case, we're just going to talk about the code portion, not the configuration portion, and let's build a pipeline. So you've probably seen this a lot as well. So you have your projects, and on your computer, and we push code to Git. We do a PR or in any case, and then that'll trigger a build in our CI tool. Now, in this case, I'm showing Jenkins here, but the tool is not important. You can use whatever tool you want: GitLab CI, Concourse CI, Drone CI, Travis CI, what have you. The important thing is what we do with it, basically, right? So we trigger our pipeline, and our pipeline ideally would look something like this. We build our Packer image. Usually we have our Packer image, and then we deploy it as part of our infrastructure. So we build our Packer image using standard Packer tools. Great. So, and then we go into our main part that's new, is testing. So two phases to it. First, we want to test our Packer image. We want to make sure that what we built is the correct thing. So if you're installing Kubernetes, let's say we're building a Kubernetes node, we want to make sure, well, that Docker is installed, that kubelet is installed, and maybe configured correctly as well. How do we do that? Well, we want to test it. And there are some ways to do it. I'll go through a few, but that's the first step. If that passes, we move on and say, okay, cool, our image is done, tested, it passed. Now let's deploy the entire thing. Let's deploy it, and first of all, we'll see if it actually deploys successfully, if there will be any errors on our Terraform apply, which is, let me tell you, good information by itself. But second of all, we should test it. And once we test it, and we say it's good, or it's passed or didn't pass, we clean it up. So this is like a single event. We bring it up and we tear it down. We leave no trace we ever did anything to our infrastructure. Usually you have a separate account for this in your cloud, or you just make sure everything is randomized. The names and IDs are randomized enough for it so you can keep it in the same account as your other stuff, and it doesn't matter. And once the job is done, we, of course, want to notify it, either our Slack channel, or maybe if it's a PR, we want to notify it to our PR and say the build failed. Now, this pipeline is very similar to, how microservices get developed, but at the same time, components are a bit different, and there are different things we need to care about. A few words about testing, right? So please make sure when you test your code, test entire deployments and not units. You don't need to test that a Terraform resource AWS instance will create an instance. Well, it will create it, right? Terraform will guarantee that to you, and you don't need to worry about those specific. But what you do need to worry about is when the entire deployment is done, is it actually done? Can I maybe log into it, or maybe just SSH into something, or curl something, or can I see the number of instances? Are they all there? How do I know? Well, that is what you should test. You should test if your entire deployment is done and dusted. And if it is, move on. So there are no standard ways really compared to like in Java, how you have you have JUnit and you have Maven and Gradle, and you have all these standard build tools that everyone uses. a lot of times you'll end up building custom tools. And I want to give a huge shout out to TerraTest and TFlint, which are two amazing libraries written in Go, which will work beautifully with your Go code. And you can use those and you build some custom tools around it. It's not a lot. I'll show you a quick example how you can actually test it, pretty easily. Even if you're not like a grandmaster in Go, you can still work with this, and it's very easy actually. And of course, the main part about testing, of course, we want to reduce risks. Our build pipeline, we know at the end of it that the Packer image is correct and that the infrastructure code we've written actually works and actually does what we want it to do. Yes, a quick note on how we can build some tests in Go. Using TerraTest, it's very easy. So if you check the build AMI function, it's just we put it some options like the template name, and we just say Packer build artifact, and it'll build it and return the ID of the build image. And then we say, okay, I want to test it. And we can use TerraTest's built-in functions. There's a lot of them, a lot more of them. Like we generate a RSA key pair, we create a temporary folder for our Terraform code. We create some options like our variables for our Terraform code, and we say, okay, we'll destroy it once the function's over, and then init and apply. And in this case, we're only testing the AMI, so it'll be a little tiny Terraform manifest that will just spin up the AMI so we can log into it and see if everything's on it, what we want to do it. So that's all part of the test. And then we check, we get the address of the output, and then we call, for instance, verify AMI, which in our case is just, see if I can SSH into it. If I can, great, it actually comes up, and we know that that works. And then we can check, for instance, okay, let's check the Docker version and the kubelet version, see if those commands are there, see if that is installed. Now, again, this is a very simple example, but do check out all the other options they have, for instance. There's a lot of them. You can check AWS stuff, GCP stuff, Azure stuff, Kubernetes stuff, and a lot of built-in functions. And you can, of course, always build some of them yourself. And then, so that was a couple of tests. And what we end up is basically more of a project structure like this. So we can see that this is a single, like let's say for our Kubernetes cluster, it is basically our Terraform code, our Packer code, and a few Go files that perform the test that you just saw. And you can add your own as you go. And those few things we just mentioned are all derived from like the deployment lifecycle of our let's say for instance microservices, and they make a sizable difference. Okay, let's finish it off and go to the next pipeline. So we did the build pipeline, and it's great. We know that this works. We tested it, every change will be tested, and if the test don't pass, the change doesn't go into our main branch. Now, how do we deploy it? Now, we noticed when I explained, don't do it manually. Instead, create a pipeline for it. Kind of like how with our microservices, we don't want to deploy them manually. We want to have a pipeline, like a kind of a promotion pipeline. So in this case, we're going to feed off our config, which is going to hold all our configs for every environment that we have our Kubernetes deployed to. And any change to that config will trigger a build. And it's going to be a different pipeline this time, and it looks kind of like this. So we run, our image was already built by our build pipeline, and then we can just do, okay, that's our code, plan, and then we see the changes that need to be made, or if it's a new one, it's going to be just everything. And then we can either do automated or manual changes. Now, whether we do one or the other, it depends on the how confident you are, basically. And as more confident as you gain with more tests, you can then slowly switch to automated tests, to automated applies. And once we approve it, we apply it, and it gets deployed. And this way, we never deploy it manually. Everything is done as a trigger, as a change in our config repo, and then applied by our pipeline. And we never have a situation where, well, something was not applied accidentally. So those are our two pipelines, our automated build pipelines and automated deployment pipelines. But in fact, because infrastructure code has this, especially Terraform has this cool feature where it can detect changes in a live environment, we can build another one. Let's add another one. Let's add the automated drift detection and correction pipeline. And in fact, we can just take the previous one and just change the trigger. So what we can do is, instead of triggering it at on every change, we run it every night. And we do a plan every night, and every day we'll know we'll check if something changed. Let's say someone changed some security groups, and we'll know about it. And then we can either review it or review it manually or automatically, and then apply it to correct it. And this pipeline can then automatically or manually correct your changes as they happen in your infrastructure. And that is a special powerful thing we can do with infrastructure code. So for instance, example how that will look, let's say it ran at night and we noticed, oh look, actually my plan, found out a difference. It looks like some roles changed in our DynamoDB table. Well, we can say, okay, cool, I want to review this. And then for instance, in Jenkins, you could do this in their tools as well. I'll just say, do I want to proceed or do I want to abort? Let's in this case, I proceeded and it ran apply and it fixed the problem. Now maybe for this, we wouldn't need to approval because it's a very simple change. But maybe for instance, if suddenly a database it says it wants to delete a database, okay, right, hold on and maybe don't do that. So abort it and then fix it manually if it comes to this sort of situations. Yes, and then we learn as you go, and then we can potentially build some custom tools which identifies which of these modules are actually, we trust Terraform to fix automatically and which we want to review, because there may be some other issue, other underlying issue. Yes, so those are our 3 pipelines, and instead of getting a big monolithic repo with no tests, automatic applies, we can build something like that. And it allows you to start small and scale out your infrastructure as you need, as big as you need, from a smaller startup to a big enterprise. No matter how you start, a model like that, taken directly from basically microservices or deployment or software development lifecycles, work brilliantly with infrastructure code, and basically it's something that everyone can embrace, and it'll definitely help you out. And on the last note, I opened up with a quote that said that it was basically infrastructure code is just something we use to describe our code. Well, if we follow through what we discussed today, is that actually maybe it's not just that. It starts there, but it's infrastructure code as a term means a lot more. In fact, one of the quotes from the book, Infrastructure as Code Manager Service in the Cloud, good book, by the way, is infrastructure code is an approach to infrastructure automation based on principles for software development. So basically, it's not only describing your code, but applying everything we've already learned and continue learning from software development and using it here. Don't hold back. Don't think that infrastructure code is any less important or any less in need of a proper management lifecycle. And it'll make you more productive, make your life easier, and above all else, less errors, more manageable. And we actually know what gets deployed, what gets run, and how we manage it. Yes, so thank you very much. That's it for me. I am right on time, I think. So thank you very much for the talk.